This summer, a portrait by a French art collective sold at auction for $432,000. Now, that doesn't sound uncommon, but this was no ordinary piece of art. It was the first painting generated by artificial intelligence and sold at a major auction house, and it sold for 20 times more than had been expected. Nearly every day, we read about AI being used in new ways. It's being used to write songs, to address diseases, to drive cars, and under the hood in all kinds of everyday applications on our mobile phones. This is exciting, and it's a little frightening. So what does it mean for us as investors and as people? Welcome back to The Bid and to our mini-series Behind the Hype, Demystifying FinTech. Today, we'll talk with Stephen Boyd. He's the chair of the Electrical Engineering Department at Stanford University in Palo Alto. He's also a pioneer in artificial intelligence, specifically in convex optimization. He's written 4 books, dozens of academic papers on control, optimization, and he literally wrote the book on machine learning with 2 of his colleagues. His open source software has been used across multiple industries, including to launch rockets and to optimize investment models. We'll talk today about the applications of artificial intelligence in investing and beyond, and whether or not AI is going to take over our jobs and, well, the world. I'm your host, Mary Catherine Lader. We hope you enjoy. Stephen, thank you so much for joining us today.
Thanks, Mary Catherine. I'm very happy to be here.
Let's just clear this up. We hear artificial intelligence used in the same way as machine learning and data science. What is artificial intelligence? Is it all these things at once? And does it even matter to define it?
That's a great question. It's not clear to me that actually figuring out, carefully defining what is AI, what is machine learning, for that matter, what is traditional statistics, makes a whole lot of sense. The truth is, there's really just a group of technologies and methods, and they have names like AI, machine learning, optimization is one, and they're all related. And I actually think that the great promise lies in using all of these methods. I don't really distinguish among them. I know there are lots of people who get very riled up and say, no, I'm a data scientist, or I don't do machine learning. I think there's a broader group of mathematical and computational methods, and the promise is in using all of them together.
In our second episode, Jeff Shen talked about how AI is used in the investment process. But the applications for AI, data science, machine learning, they go far beyond that in financial services alone. And they could span anything from improving operations to how we engage and interact with clients. So what are some of the most interesting uses of artificial intelligence you've seen in finance?
You asked about what's especially interesting about finance. And in fact, I think if you don't mind, I'll respond with the exact opposite. What I find really interesting is actually the commonalities between different industries and applications in these areas. You know, I've worked with people doing aerospace, energy systems, machine learning, fraud detection, and they all have their own dialect, their own set of problems. These dialects are usually mutually unintelligible. What's really interesting is that when you listen and start figuring out what they're saying is actually how common the problems are across these fields. I mean, it's crazy to think that, for example, electronic circuit design would, once you understand really what's going on, have a lot of commonalities with, for example, fraud detection or aerospace problems. I mean, it's very, very interesting to me.
Does that mean that you see learnings from other industries that are useful in financial services and fintech? And if so, could you give an example?
Sure. I mean, one is the whole area of models. And how do you use models? How do you create models? How do you validate a model? After a while, after you've seen it in a couple of different industries, then in fact, it does become very useful to pull one idea from one industry or application to a completely different one. Here's one. Almost everyone who builds models knows that they're wrong. They may be useful, but they're probably going to be wrong, and that things may change and they become bad. And then the question is, how do you test a model? How do I know that my model of, let's say, returns, or for that matter, my model of consumer demand or something like that, how do I know that that's still a good model? The different places, different industries have different ways of doing this. I mean, it's very interesting to take stuff from one and take those ideas to another one.
If models are wrong, then what can you do to account for the uncertainty? I mean, you've worked in extremely high stakes areas, ranging from software that launches rockets to designing models that manage billions of dollars. So, what does it mean if the models are wrong?
To answer your question, how do you deal with the uncertainty? That's the real essence of multiple fields. Finance, it's everything. That's the whole point. If you knew what the returns would be, it's game over. You know exactly what to do. And the whole point of finance is that you do not. Actually, those two applications are much, much closer than anybody might imagine. If you wanted to land a first stage, let's say, you would basically solve an optimization problem planning out all of your actions from right now until when you hit that landing pad. You'd plan a whole trajectory. Now, that trajectory is based on things like the winds when you get down near the landing pad, all sorts of stuff that, in fact, you don't know. But you make predictions and you make that plan. And then what happens is a tenth of a second later, you do the whole thing again and you replan and you execute the first one. What's crazy is that's exactly how portfolio optimization works, right? If you have a portfolio and you want to know what should I trade, then the typical way to do it is to actually make a plan based on future predictions of what's going to happen with risk and return and with things like transaction costs. Then that's your plan. You solve an optimization problem and you execute the first one, and the next day or the next hour or the next minute, you do the whole thing all over again. So those two, even though they just sound and look wildly different, at some very basic level, they're almost the same problem. And there are other areas too, like control systems, right, where you can make predictions about what's going to be happening on the road or something like that, or winds as an airplane is landing or something, or all sorts of stuff. But those are not going to be right. And so many applied areas, the real focus is exactly how to handle the uncertainty.
So, speaking of uncertainty, when people hear the term AI, it often sparks a mix of emotions today. Many people sort of fear it and might see it as a threat to their job, their way of life, and our utility as humans in a number of ways. Are those fears justified?
I mean, I think they certainly could be. It's not a function of the technology, right? Those are social and political questions as to how we deal with AI and AI-related methods as new capabilities come in and things like that. But I should say that in all the areas I've seen, this hasn't happened. For example, let's take circuit design. Well, it used to be done by people who would sit down and draw circuits out and simulate them, and after a while say, oh, that's cool, it works, and then, ship it off or something. A lot of that has been automated, and people were very worried about, well, there'll be no more circuit designers. And the truth is, that's not what happened. What happened was the circuit designers simply moved up the food chain, and they let the things that could be done automatically be done automatically and efficiently. And in fact, their work became much more interesting because they became, instead of the masons, the architects. They were the ones laying out the high-level idea of what the chip is going to do. And then the low-level stuff that probably wasn't that much fun anyway, that's what was automated. It changed how people work in that field, but I think very much for the better. And I think they would all agree, too, that it's just a much more interesting and fun thing to do. But there are tons of other examples like that. I think the point about this is that the most successful applications couple people and machines. Some people even they have a weird name for this. It's kind of a silly name. They're called centaurs, right? So it's half machine, half people. But in some sense, all applications are that. You have the people who architected the AI and the machine learning and implemented it. You had the people who tuned it to make it work. So all of these things are really a combination of the people designing these things and running them, and then the machines who actually execute a lot of the parts that, in fact, would be kind of boring.
I'd never heard that centaur phrase before. And while as I think about my own attachment to my smartphone and computer and the like, feel like I may be well prepared for that future.
Now you know that when you're holding your phone, you're a centaur. So
Exactly.
It's not a pretty picture, actually. Yeah,
right.
sorry.
It's fraught. It's complicated. These things make our lives so much better, but also distracted and a number of other things. So I'm curious, how can we prepare ourselves for that future, both as workers and then more broadly, what do you think we need to be doing at even at a higher level to make sure that we're ready for the centaur invasion?
I would say that first and foremost, it'd be really good to really understand what these things can do And also very, very important, what they cannot do. Right now, so overhyped and so overheated. I mean, when our PhD students finish and even our master's students finish, they say, I have a PhD in deep neural networks from Stanford. The offers they're getting absurd. And so this is all hideously overhyped. A lot of people get very nervous. They say, oh no, oh boy, if a computer can beat a Go champion, what's going to happen to me or something like that. This is just not right. And actually, they're a whole lot simpler. I'm going to let you in on a really dirty secret right here. These things are a whole lot simpler than some people would like you to think.
We like to think at BlackRock that our problems are really complicated. And part of what we're excited about having you and several of your colleagues as leaders of our artificial intelligence lab is to help simplify some of those and bring it back to reality. So I'm curious, could you just talk for a moment about what you're doing at the lab, what you guys are working on?
Sure. And by the way, that question was absolutely perfect. I mean, that's kind of what we do. Everyone's practical problem is super duper complicated. I mean, if you talk to somebody who did supply chain, right? They would tell you all about, there's this, then that, and you can't do this, and I forgot to tell you before Thanksgiving X, Y, and Z happens. There's all sorts of crazy stuff. We're not entirely academics, and we're also teachers. And the whole point is that usually the first step in solving a complicated problem is to abstract it and to say, sure, the details are complicated, but in fact, what's really at issue, there's really only three things going on here, and they can be very complicated. This is different if that's a bond, and this is different if that's a derivative, and it's different if that's an ETF. But to see the commonalities, because that's actually when you can start coming up with methods for them. Another great advantage of that, and that is when you come up with general methods, they often apply to other areas that you had no intention of addressing. So someone comes up to you and says, oh boy, you must help me scheduling my high-speed trains. And the point is you work out and you do stuff that would help them do that. But in the end, you realize wow, I can use the same ideas to actually do things like allocate resources at a data center. That's actually sort of the fun, but it's also the power of academia.
And you do make it sound so simple to simplify. On that note of thinking about the big picture, thinking that lies ahead of us and how things that today seem really compelling could become reality, I'm going to end with a rapid fire round and just ask you when you think these four things will come to life in 5, 10, 30 years or never. Ready?
Okay, sure.
Okay. How about autonomous vehicles?
Oh, no, that's you don't have zero on your list here. That's already here. We'll put it this way. It's here in Palo Alto.
How about human life on Mars?
Ooh, I'm going to go with 30 years on that one. Yeah. It could even be never, but I'm going to go with 30 years. It's not going to be 10.
How about commonplace use of gene editing?
That's coming. I mean, of course, it is done now in small amounts. I think in 5 years, you're going to see a whole lot more, and in 10, a whole lot more.
And what about when electric vehicles will exceed the number of gasoline-powered vehicles?
That's a good question. I'm going to go with, I would like to say 5 years, but I'm going to say 10. That's what I'm going to say. That's a guess at 10.
As I recall, you get around Palo Alto on your bike. Is that right?
I do. That's right.
Perhaps neither of those is that relevant to you, but
yeah.
In any case, we appreciate your expert opinions on all of the above. Thank you so much, Stephen, for joining us today.
Oh, Mary Catherine, it's been my pleasure.
To our listeners, we'll be taking a break for the holidays, but we'll see you in the new year. Thanks for listening.
This material is intended for U.S. distribution only. This material is for informational purposes and is prepared by BlackRock, is not intended to be relied upon as a forecast, research, or investment advice, and is not a recommendation, offer, or solicitation to buy or sell any securities or to adopt any investment strategy. The opinions expressed are as of December 2018 and are subject to change. The information and opinions contained in this material are derived from proprietary and non-proprietary sources deemed by BlackRock to be reliable, and are not guaranteed as to accuracy or completeness. This material may contain forward-looking information that is not purely historical in nature. There is no guarantee that any forecast made will come to pass. Reliance upon information in this material is at the sole discretion of the listener. Past performance is not indicative of current or future results. This information provided is neither tax nor legal advice, and investors should consult with their own advisors before making investment decisions. Investment involves risk, including possible loss of principal. Copyright 2018, BlackRock, Inc. All rights reserved. BlackRock is a registered trademark of BlackRock, Inc. All other trademarks are those of their respective owners.